All right, so test 6. Let's take a look at the topics. So first, 5-1 and 5-2. 5-4 and 5-5. And I'm grouping them like that when I say it. And then 6-1. Okay, these two sections we're going to go over are going to be our rules of exponents. The video you were watched like 3 or 4 weeks ago. This section has to do with rational functions and simplifying them or multiplying and dividing. And then this is the roots of real numbers that we did yesterday. Okay? To give you an idea as far as the format goes, you're going to have 4 multiple choice questions to start for 2 points each. Okay, those are going to be a mix of all the sections. One of them is rational functions, 2 of them are exponents, and the third one is rational functions. Then you're going to have 6 free response questions, and those are going to be simplification problems. So you're given a rational function or something with exponents, and you just need to simplify it. Okay? And those are going to be worth 4 points each. Free response. Free response, sorry. And these, again, these are going to be like simplification problems. If you look in your homeworks and all of our notes, you'll see we have a lot of those. Okay, where you're simplifying a rational function or some sort of expression. Then you're going to have 4 problems on roots of real numbers, where you're going to have radicals involved in the problem. And you need to just give me the equivalent expression. So like the square root of 25 is 5. Like that's an easy one. But you might have the cube roots and stuff, and we'll go over those today. Worth 3 points each. Okay? And then the last 2 you're going to have are going to be where you have to solve equations using the square root, like we did yesterday in class. Where we had an equation like, now I'll do an example, where we had an equation like x squared equals 36. Solve for x. It'll be a little more complicated, and we'll do an example of that. But these are going to be ones where you solve for the root. Okay, and these are worth 3 points each. And that's it. Alright, so again, it's going to be a total of 16 problems. Yeah. It's only front and back on a sheet of paper. So I'll give you, if you like, if you need to take a lot of time, you can, but I presume that most people will be done within like 30 minutes or so. Okay, but if you need to take 40, 45 minutes, that's fine. But it shouldn't be a problem as far as time goes at all. No calculator tomorrow. Okay? You're not going to need it. It's not going to help you. And to be honest, for these problems, with a calculator, if you use your calculator, it doesn't show me anything as far as what we know. I want you to be able to simplify roots without a calculator. So for example, the cube root of 8, well that's just 2. Because 2 times 2 times 2 is 8. That's stuff that you need to know up here, not on your calculator. Okay? So you're not going to be using a calculator on tomorrow's test. On your midterm, you will be able to use a calculator. Alright? Okay, let's get started. Let's take a look. First, let's start with section 5.1 and look at some examples. So if we start with something like this. How about something like this to start? Okay, where we're going to simplify an expression that has different exponents. Now, there's many ways you can start these problems, first of all. So I'm going to show you one method.
Is the b 0?
Yes. I'm going to show you one way to do it, but again, you can approach it different ways. So, first, you could start by looking at the fact that there's a -2 for the c, and think about what that means with negative exponents. Anybody remember for negative exponents, what do you do with them? Johnny? Good. So you'd make this like a c to the positive 2 and flip it or move it down on the bottom. And remember, only the things that have a negative exponent move. Nothing else moves. So in this entire expression, the only thing with a negative exponent is right here. So nothing else is going to move, meaning top to bottom or bottom to top in this case, except for that. Now, before I do that, before I move it, I could just start by distributing the 3 also. So it depends on how I want to start this problem. Let's make it a little more tricky also. Let's put a 2 in front of here. Okay? Put a 2 in the very front. Now, this 3, this third power, is on the outside of the entire fraction. So not only does it get distributed to the numerator, but it also gets distributed to the denominator. denominator. Okay? If you would like to, you can simplify what's inside first and then distribute the 3. That works also. So any approach is fine, and it's up to you to decide which way you want to go. I'm going to start by distributing the outside part, and that's what I always do. Whenever I see an exponent on the outside, or even like, you don't have to write this, but like something like this, like even if it's just on the top, I would distribute that to the top first, and then I would start to simplify. But I always take care of whenever I have a major parentheses first. It just, to me, it makes it easier. But again, it's up to you. If you want to simplify what's inside first, like cancel out your A's and B's and C's the way you should, and then distribute the 3, you can do that as well. It doesn't really make a difference in this case. I'm going to distribute the 3. Now, when I distribute the 3, all of these really pretty much put the 3 in the exponent for each of them. So this becomes 2 to the 3rd here. And 2 to the 3rd is 8. So we start with an 8 there. Now what about 8 of the 2nd to the 3rd? What do I do when I raise a power to another power? Multiply the powers. Okay? Multiply the powers. So this becomes a to the 6th. Again, because I'm taking this 3 and I'm multiplying it. But remember with the 2, a lot of students make this common mistake and they make this a 6. It's not 2 times 3, but it's 2 to the 3rd, which gives us the 8. But the exponent you are multiplying. Manny, the next one? Why is there a 2 in front of the? It's just part of the problem. Yeah. I said that already. Okay, you must have just been writing something down, yeah. Okay, so what about the B part here? What about the B part? I'll have it. B to the 9th. Okay, again, because I'm doing this 3 times this 3 right here. Okay, B to the 9th. And the last portion, C to the negative 6. Where did the negative 8 come from? Just so I know. Okay, just a little. Okay. So negative 2 times 3 gives you negative 6. Now the denominator, let's distribute. What is the exponent for A? And this is something that people always confuse. What is the exponent? It's a 1. Good. So then you do the 1 times the 3, which gives us? Good. So A to the 3rd there. How about the B to the 0? What's anything to the 0, everybody? 1. Anything to the 0 is always 1. Always 1, always 1. And if you want to check that, look at the video. I showed you exactly how that works and why that works. So please make sure you know that. Anything to the 0 is 1. So if I just think about this is just the number 1. That's all it is. So I can think of this and just go like this in my mind, just put a 1 in its place. But what's 1 to the 3rd? It's still 1. So does this have any effect on the problem at all? Everybody? No. If you multiply anything by 1, it's the same thing. So this 1 here for the B to the 0 does not matter. So whenever you see something to the 0 power, start by replacing it with 1 automatically. And just pretty much ignore it. Okay? And the last part, C to the 4th, to the 3rd, C to the 12th. Alright, so again, this 1 really doesn't matter. So I'm just going to put a line through it from there. At this point in time, a lot of people might choose to start simplifying. I would move my negative exponent first. I would always move my negative exponents next. It makes it easier in the end. So really, there's a negative 6 up top, so what should I make it? On the, good. Positive 6 on the bottom. So write C to the 6th here, and just cross this off. Okay? Again, whenever it's a negative exponent, you move it to the opposite location. If it were a negative exponent in the bottom somewhere, where would I move it then? To the top. Okay? If everything in the entire problem had negative exponents, I would literally switch the entire problem then, right? Because everything in the bottom moves to the top as positives, everything in the top moves to the bottom as positives. So at this point in time, now we can start trying to simplify things. And see there's 8 here, there's no number in the front here. So I can't reduce to 8 at all. The 8's going to remain up top. Next, I look at my next variable. I see there's a bunch of A's listed. Now, this is how I want you to think about this. Don't use the rule where you have to subtract the 2 exponents. Okay? There's no real need for that right now. It is a good rule to know, and you should know it. But here, think about it this way again. Okay, that's what's really going on there. there's 6 A's up top, and there's 3 A's down below. Are we all clear on that? That's what that means. So just do this now. Just take these 3 A's and cancel them with 3 of these A's. How many does it leave behind? Summer. Where? Up top or bottom? On the top. So this is just a to the third.
What if you have like 8 to 25?
Well, yeah, you're not going to write it. I'm saying this is what you want to think.
Oh, okay.
Yeah, do not, guys, you don't need to write what I'm writing here with the A's. But I'm saying think about it that way, okay? If you have 8 to the 25, think about 25 A's, and imagine you have 10 A to the 10th in the bottom. Then 10 of those cancel with 10 of those, leaving 15 behind up top. Okay? Yes, but you know what happens, Manny? If you have 6 up top, and then you have a 12 down below, people do 6 minus 12, which is negative 6. And then they're confused as to where it goes. Does it go on the top, the bottom? And then they forget and they leave negative exponents. So this is just a way to avoid those errors. Okay? Whenever you're simplifying an expression, your final answer needs to have all positive exponents. Okay? All positive exponents. So doing this might be a little bit more useful than subtracting, because then you end up with a negative exponent, and then people put it at the bottom when it should really be in the top, and then you have to actually move it down to the bottom after. It's more work. Okay? So use your brain a little bit. Think about it this way, please. Rules are good, but sometimes there's no necessity for a rule. There's b to the 9th up top. Is there any b in the bottom? So, what happens? Yeah, just keep it. So b to the 9th up top still remains. And how many c's are in the bottom, Jules, altogether? 18. Very good. Okay, again, yes, you can think of adding the exponents. That's right, and that's the rule. Or you can think of there's 12 there, there's 6 there, so there's a total of 18 in the bottom. Okay, and this is the simplified answer. Again, notice all of the exponents are positive. They're all positive. Okay?
For our next problem, can we look at something from the problem set? Because like one of them might like be all confused about.
Okay, do you have a specific problem?
Yeah, I think it's like number 40.
Just read me the problem.
40, 5, 4. So it's
We did this one yesterday, I think, after school. The ladies over there yesterday.
okay. So I think it's like x squared plus y squared minus z squared minus 2xy. And then on the bottom it's x squared.
This is not the section here. We're not on this yet. Okay? When we get there, we'll get to it. Sorry. We're still doing exponents.
Oh, it's the really long one.
It's the really long one, and we're not going to go over that one. If you want to see that, you should have come after school yesterday, or ask one of the ladies to help you with that. I went over that. It took us about 10 or 15 minutes to do that one problem, so I'm not going to go over that one, I'll tell you that. But if you want to, I emailed them all the notes we did yesterday. They can help you with it, okay? All right, let's take a look at another example from 5.1 and 5.2. What if we had... What about something like this? What approach should I take to start this problem? There's an easy way and there's kind of a tougher way to do it. Sorry.
The expression on top equals 1.
Yes. The entire numerator is just 1. The entire numerator is just 1. How come, Johnny? Why is the numerator just 1 in this problem? Yes, because the whole numerator's exponent is 0. So everything has a 0 now. By default, these all become to the 0 power, like this, when we distribute the 0. So everything to the 0, all 1, so it's like 1 times 1 times 1 times 1. So just start by putting a 1 up top. And now the problem's a lot easier. Okay, Manny, what should I do next?
Put b to the negative second and b to the negative fifth on top.
Yeah, very good. So I'm going to move the other 2 up to the top now. So let's take the negative exponents, let's take these portions and move them up to the top. So what does it look like, Manny?
It's going to mean b to the second times c to the fifth all over 2a to the third.
And can I go any further? Is there anything else to do? No, there's nothing else. And that's it. Okay? So if you have an entire quantity to the 0, replace that entire quantity with 1. With 1. Okay? One more for this section. One more. This is what I'm thinking about. I'll put it up here. I'm thinking about this as the following. I'm thinking about it like that and like this. Because I have the negative third around the whole thing, so it's like the top and the bottom both have an outer exponent of negative 3. So what Nick is saying is, you know what? These are negative exponents, the whole expression. So you can take this entire expression, here, and move it to the bottom with a positive 3 exponent. Take this entire expression, move it to the top with a positive 3 exponent. So the easy way to do it is what Nick said. When you see a negative exponent on the outside of the whole thing, just write the reciprocal of the fraction and make it a positive 3. So let's rewrite this with the denominator and the numerator now, 3x, y to the negative 4. Notice I'm not taking into account the negative 4 yet for the y. That's what we'll do afterward. Okay, I'm just literally taking the reciprocal. 2x squared y, and the whole thing is now to the positive third. Again, all that's happened here is that the numerator and denominator have flipped. We've written the reciprocal with a positive 3. Because by definition, a negative exponent is 1 over that value. So if we just flip them both, we're doing that in one step. And it really does save you time. That's why I asked for the suggestion. Very good. Nick, what would you do next?
I would flip the y. Just
Okay, that's fine. No, you see what he said? And that method works. You can distribute the 3 to each, or you can move the y first. Let's do that. Let's move the y first. So if I move the y to the bottom, it becomes y to the positive 5. Because this is really y to the 4th, and this is going to be, so this one moves down, like that. Then it's going to be y to the 1, and y to the 4, which is really y to the 5th. Is that clear? Nods, yes, no? So an idea? If it's not, just ask. I don't mind continuing to talk about it, but I want to make sure I'm not wasting your time. So we take the negative 4, move it down as a positive 4. This becomes a positive 5. And just kind of get rid of that now. Okay? All right, let's keep going now. Now we can distribute that 3, right? Now, if we wanted to, we could simplify the x's first also. Right? We could simplify the x's there and then distribute the 3. It doesn't matter. Just for the sake of doing it differently, let's simplify the x's now and then we'll distribute the 3. I've got, how many x's up top, everybody? 1. How many down below? So one of them cancel, right? Leaving behind how many? 1, and is it in the bottom or top? In the bottom. Again, this is like having x and x down here. This is like having an x up top. One of these x's cancels with this one, leaving behind just 1 on the bottom. So just do this. Cross this off, and just get rid of this exponent. And I'm going to write it neater so we can see it before we distribute. This is what we've got now. That's what we've got from that stage. Okay? We've got a 2 in the bottom still. We've got the x left behind, y to the 5th. And the numerator simply has a 3 now. Now we have to raise them all to the 3rd power. Pete, when I raise the top to the 3rd power, I do 3 to the 3rd. What do I get when I do 3 to the 3rd?
Well, 18.
Be careful, 3 times 3 times another 3. 27. There you go, good. What about the bottom, Pete? If I raise 2 to the 3rd, 2 by 2 by 2.
8.
8. Well done. Okay. I'm staying with you, so be careful here. How about the x now? What's the exponent really here?
Well, so 1, so it's 3.
Very good. Well done. There's really a 1 here. And then the last part?
15.
Good. Okay? So make sure we all see that. When you raise the exponent to another exponent, we're multiplying them. Whereas when we raise a number to an exponent, we're actually evaluating. Okay? There's nowhere else to go because 8 and 27 can't reduce. If 8 and 27 can reduce, then we would do that. But they cannot. So we leave it like that. Notice all positive exponents. All positive exponents. Any questions on this one? So that's 5.1 and 5.2. That's the gist of it. Now, please be careful. Because I'm telling you now that you're going to have multiple choice with these as well. And when you have multiple choice with these kinds of problems, you have to be very careful because one little mistake and what happens, then the choice isn't there, right? Okay? So be very careful with these ones. All right, let's look at section 5.4. And Nick, just to answer your question from earlier, the one you asked about, something that complicated won't be on the test. Not saying you shouldn't know how to do it, but it won't be on the test tomorrow, okay? But still, talk to the others and see what you can do for that one, okay? All right. In section 5.4, we did two things. Look at your notes. What was the first thing we did in section 5.4? We did two real things in section 5.4. What was the first thing we did in 5.4?
Simplifying rational expressions.
Good. We simplified a rational expression. Now, that might have looked like the following. X squared minus 9 all over x squared plus 5x plus 6. And we simplified it. Now, what's the common mistake in this kind of a problem that some students might make? Not you guys, obviously.
You're going to try to reduce x's or whatever. It's not possible.
Good. You cannot cancel out the x squareds. How come, Annie? What are they called? Add-ends. Add-ends. X squareds are being added to the other things in the problem. You can't just cancel add-ends. What can you cancel, though? Factors. So let's factor the problem by default. Nick, what do I get when I factor this one?
The top or bottom?
Either. Tell me whichever one you want.
X minus 3x plus 3.
Good. Now, Nick, because you see x plus 3 and x minus 3, what might you think is in the bottom?
Oh, then x plus 3 and x minus 3.
Yeah. Again, whenever you're simplifying rational expressions, there's a good chance that something in the top also appears in the bottom. So when you see this minus 3 and you see a plus 3, think about the number 3 automatically. Okay? What numbers multiply to give me 6, Summer, and add up to 5? 2 and 3. Very good. Both positive, right? What do I do next?
Cancel the x plus 3.
Leaving us with?
X minus 3 over x plus 2.
Mahanor, why can't I go any further in this problem? Why can't I just cancel those x's? Yes, because they're add-ins. Again, the x's are add-ins. What do you think, if this were multiple choice, might be a choice to try and trick you a little bit? Yes, -3 over 2 is definitely going to be a multiple choice answer because some people might just try and cancel those x's. Is that clear? So again, when we simplify rational expressions, we must think about factors. From 5.4? What is the problem from 5.4? Okay, this is a good one because this is something I like on your test. Very good. X squared plus 2x minus 8 all over?
2 minus x times
Okay. This is something you should definitely know for your test. Now, we're going to factor the start, right, Alejandro? And when you factor the top, what does that factor into? X minus 2, x plus 4. Who can help us with this part now? It's like not a trick, but there's something you should recognize in this problem. Nick?
Do you pull out a negative?
You can think about pulling out a negative. Very good. Now, before I do that, Nick, there was also like a rule that we used, or something that made this even easier, just to reduce the two. Right? Okay, the x plus 4 and the 4 plus x cancel. Because remember, addition is commutative. So I could rewrite this as x plus 4, right? Isn't that the same thing? 4 plus x, x plus 4, it's the same answer. So really, these end up canceling, definitely. There's one other thing I can do, Jules.
It's like a minus b over b minus a is like 1.
Careful.
1 half.
-1. That's what it is, okay? So our final answer is -1 in this problem. Again, yeah, so I can show that step. So let's see what we have here, and I'll demonstrate it. Because I did this earlier this year, but I know it was a while ago. This is what we're left with, correct? Right now we have this. As Nick said, in the denominator, factor out a -1. Think of this as look at the denominator that way now. If you take out a -1, the positive 2 right here becomes a -2. The negative x becomes a positive x. So really, now look at the numerator and denominator's factors. minus 2, and then this bottom here, negative 2 plus x. Those are the same things. You have a negative 2 in both cases. Here's the negative 2. And you have a positive x in both cases. So these cancel. But don't forget, when you cancel something in the top, what do you have left behind, really? There's a 1 left behind. So your final answer is 1 over negative 1, or as Jules mentioned, a minus b over b minus a is just negative 1. Okay, so the final answer to this one is just negative 1. What number was that, Alejandro?
Number 15 and 5.
Okay, in case you're doing your problem sets.
That's not wrong, so wrong.
Homework, yeah. Thank you. Okay? That's a good example of that. Now, there was a second part to section 5.4 that we did. What was the second part of section 5.4 that we did? That we had to figure out? It's in your notes. In your notes. Look at maybe example, I think, 2 or example 3 in your notes from section 5.4. Yes, the zeros and the domain. I'm telling you now, this is definitely part of it. So let's look at an example of this. Okay. Given the rational function above, determine the zeros and the domain. The zeros and the domain. Now, first, let's start with the domain. What causes something to not be in the domain? If it makes the fraction what? Not real, or be careful, it's not the term you want to use. You're on the right track.
Not determined.
Not close. The word is not determined, but it's another word.
0 on the bottom.
Yeah, which makes it undefined. Not real comes about with the radical. Okay? When you have to think about the radicand being positive. This, we have to think about what would make this denominator 0 and thus make the rational function undefined. So to determine what makes the denominator 0, what should we do? What should we do? Okay, but before, yes, absolutely, but even before that, factor it out. Good. Let's factor this first. So let's rewrite g of x in its factored form. Okay, you're going to see that we're going to do a lot of this in the next few chapters. Okay, we're going to be graphing functions that look like this later on this year. And what we're doing now is very key. In the denominator, factors for the denominator here. Then,
X plus 3, X minus.
x minus,
That's it, X plus 3, X minus.
good. Numerator, somebody else, numerator. Erickson,
X plus 4, X plus 3.
good. Now, first of all, you're going to notice that the x plus 3's cancel. You see that right there? But before we look at the cancellation of the x plus 3's, let's also determine the domain, because it's going to affect the problem. Okay, it's going to affect the problem. Now, what values make the denominator 0?
Negative 3 and 8.
Yeah, how come? Explain.
If it was negative 3, x plus 3 would be 0.
Good, so when x is negative 3, it makes this factor 0.
And when x is 8, minus 8 would be 0.
Yes, when x is 8, it makes that 0. So anything that makes either of these factors 0 is what is not in my answer, okay, or what is not in the domain. Remember, what we're trying to figure out is what values x cannot take on, or what is not permitted in the domain. So when we write our domain for this answer, we would say the domain equals x cannot, well, let's say domain, colon if you want to here. X cannot equal negative 3 or 8. Okay? X cannot equal negative 3 or 8.
So we don't have to write all real numbers or something.
The notation is not as vital right now, and we're going to go over the notation later on, but for now it's not really that important. But we will go over notation when we get to rational functions. So that's my domain. Even though these cancel, right? These cancel each other out, it's not like it's gone, because if you go back to the original, a negative zeroed for g of x. Now, here's a little question for you. What makes a fraction 0? What would make a fraction 0? That would make it undefined. There you go. Again, and that's the key here. We have to remember this, people. The only thing that ever makes a fraction 0 is if the numerator is 0. If the denominator is 0, it's undefined, right? So, what we care about is the numerator at this point. And if you look at your notes, we wrote down a rule. We said the denominator affects the domain, the numerator affects the zeros. That was our conclusion we made that day. So make sure you remember that again. The denominator is what gave us the domain earlier. The numerator is what's going to give us the zeros. Is that clear? Okay. Now, what would make the numerator 0? What would make the numerator 0? Pete, what do you got for me? What would make this 0 right here?
4 or negative 4 or
Ne- Or?
negative 3.
Good. So negative 4 or negative 3 would be my zeros right away. Now, the only thing about this that's tough is that, yeah, negative 4 makes this 0, sure. And negative 3 makes this a 0. But when I put negative 3 in, didn't we say we can't have negative 3 a minute ago? So we actually have to reject one of our zeros. And this is what we did in class. So for the zeros of this function, you would start by saying, those are my zeros of the function. I agree. But then you have to say this. Reject the 0. How come? Because negative 3 cannot be in the domain. It is already stated up top that x cannot equal negative 3. So even though it looks like negative 3 is going to be one of the zeros, we have to reject that solution. Because it was stated earlier that it can't be in the domain. And that's the reason that I started this problem by looking at the domain first. Alejandro.
What would happen had you solved for the zeros first?
You would write these both out, then you would do the domain, and you would have to realize, oh wait, now the domain says it can't have negative 3, go back and reject it. So you can do it in the opposite order, but you got to remember to go back and check your zeros to make sure that they're allowed in the domain. All right, let's do one more from section 5.5 now. I don't want 5x. Let's say 6x.
How do you write the notation for the zeros?
X equals this, x equals that. You're looking for the x values of the solution to the numerator. This is section 5.5, okay? Where we multiplied and divided rational expressions. First rule when you see this problem, what should we do right away when you see this? Flip the, which one? How come? Good. Division is defined as multiplication by the reciprocal. So immediately flip the second term. So rewrite the second term as, and I'm just going to erase it, okay? Just to save time. Okay, rewrite the second term like that, and instead of division, make this multiplication. Now, it's tempting to start trying to cancel the x squares, but we know we can't do that because they're addends. So what should I do for this problem, Nick?
I would just, can you cross cancel?
Sure, but I can't do it now. There's nothing to cross cancel. We have all addends everywhere. X squared, those are addends. These are addends. We still have all addends. There's nothing to cancel as of right now. No, not yet. Summer? Factor everything. Factor, then cross cancel. So you were one step ahead, okay? So factor first. If you multiply everything, you are going to get a messy answer. It's going to be x to the 5th power. You're not going to want to do that. Then you have to refactor it, which is just way too much work. So let's start by factoring to start. ones should be second nature by now because we're so good at factoring from our last chapter. And now we just start to do some magic. Let's cancel. May, step me through the cancellation.
X minus X plus 4, X plus 4.
Where? Top, bottom, where? Okay, next.
X minus 3 to the X plus
Good. Next. Good. Next. Good. Next. Good. And I wanted to make sure you didn't cancel them. Well done, man. So we have 3x over x minus 3. And it's tempting to cancel the 3's. If people see those 3's, and because they're so in the flow of canceling, they just cancel the 3's off. Okay? But remember that they're not factors. X minus 3, those are both adds. Okay? Is that clear on that one? I'm going to fly through this, I know. I'm going a little quick because we're about to run out of time. Section 6.1. And this one we did as recently as yesterday. Okay? So, section 6.1, you should know how to do the following. You should know how to do any roots. So I'll give you examples. The fourth root of 16. What is the fourth root of 16? Anybody? What is it? 2. Good, because 2 times 2 times 2 times 2 is 16. Remember, what are we doing? We're thinking about this like the following. Blank, 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 blank. What would fill in those blanks to give me 16? Well, 2 would fill in those blanks. So the answer is simply 2. What about the fourth root of negative 16? Not possible. It's not real. Okay, not real. Please look at your odd roots as well. Okay, so like the third roots and the fifth roots also. The last thing was solving equations, so try this tonight. Okay, try something like that tonight, please. 3x squared minus 75 equals 0. And then also try something like this.